Okay, good morning, good afternoon. Hello, everyone. We had a little intro video, but it was not working. So we'll go ahead and get started. Thank you for joining another one of our meetups. Oh no, I have background noise. 1 second. Sorry about that. So thank you for joining another one of our virtual meetups. We are joined today by Javier from IBM, who's going to be presenting a really interesting talk. Real quick, we'll go through a few agenda items. So introductions from the Elastic side. My name is Olivia Petrie. I'm a DevRel program manager. I'm also joined by senior developer advocate, Justin.
Hello, everybody. Nice to see you.
Perfect. So real quick, we'll cover our usual meetup raffle. We have the presentation, which is the main reason we're here today, and then a Q&A at the end. So getting into it, if you've attended one of these meetups before, we usually like to do a little raffle. So if you have time, feel free to fill out. It should take less than a minute, and you could win some Elastic swag. So I will post this link in the chat. Also, you can scan the QR code if you're super quick. But no worries. I'll also post a few other resources, including our Meetup Pro dashboard, where you can take a look at upcoming in-person and virtual events in your area. We have over 140 user groups globally, so we're staying busy, whether it's an in-person or virtual meetup. And then to piggyback off of that, if you're ever interested in presenting at one of these meetups, we'd love to hear from you. We want to hear from the community, whether you're new to Elastic, whether you're an advanced user, definitely reach out to us. So meetups@elastic.co is the best way to reach us, and we'll direct you to the right team member, and we'll get the conversation started. So with that, I will turn it over to Javier. And there he is. I'll remove my screen. Javier, your presentation's good to go.
Thank you. Thanks a lot for that introduction. So my name is Javier Francés. I come from IBM. More specifically, I come from the customer success management team here at IBM Spain. And my role is to help clients feel comfortable with the technology they acquire, and so supporting them through their whole journey in any project. And today I will be presenting my master thesis, so a project with a collaboration with the University Carlos III of here Madrid. And the project is enabling multilingual tabular Q&A, as we will see during this presentation. And more specifically, how can this be achieved with our technology, watsonx, and of course, Elasticsearch. So in this presentation, you will see that we will make use of an Elasticsearch service as the knowledge base and as the backbone of the solution of this project. So let's get on with the presentation. And of course, feel free to ask any questions in the chat. I would love to hear your feedback. First of all, a short disclaimer. This project was developed for a master thesis, and so the Spanish government was not involved, even though we made use of the data that is publicly available in their portal. And this data is for public access, and so it was a great source of data for this master thesis. Let's get on with the agenda for today. We will start by taking a look at the motivation for the project. I think it's really important to understand why we started this project and what we wanted to achieve, or what we wanted to showcase with this solution. Then we will move into the solution architecture. So what are the different components and different building blocks, among which we will find, of course, the Elasticsearch solution. We will also talk about the data and the data processing and storage that has been done for the purpose of this project. We will also talk about the virtual agent that has been developed to act as an orchestrator or as a retriever in this solution. We will look into the generative AI integration that has been developed for this project, which right now is an incredibly relevant topic. And then we will finish with a quick demo showing the actual solution, because of course PowerPoint presentations are great, but we always like to see demonstrations and real things. And also the project outcome. So what have we achieved with this project? and what could be some possible future work if we wanted to extend this project and bring even more value to the users that are making use of it. And of course, some Q&A, but feel free to ask any question. Here's some self-promotion. Here you have my QR code for my LinkedIn page. If you have any questions after this presentation, also feel free to add me on LinkedIn and ask me any questions you feel, or any feedback, of course, you have about this presentation, both good or constructive, of course. So let's get on with the motivation of this project. In this project, we have developed a RAG framework. So just as a short summary about RAG, I'm sure everyone now has heard hundreds and hundreds of times what RAG is, but just in case, RAG involves a user asking a question to a system. But we're not going to ask the question directly to a large language model. Instead, what we are going to do is ask a question to our knowledge base in a solution. This knowledge base contains data that we control and that we know that is of highest quality. We are going to retrieve the top results that should answer the question of our users, but might as well not answer the question. We are going to build a prompt containing the query and the retrieved relevant context, and then we are going to prompt an LLM with this text. The LLM will generate an answer that, of course, we hope is correct, and also it will generate an answer together with the source of information. So from which document have I obtained this data? And this will be presented to the user in the form of a complete and coherent answer. And so let's look a little bit more into the knowledge base of the solution, because I think it's the important aspect, especially in this Elasticsearch meetup. So in order to build this RAG solution, it's crucial to extract the information from our data source and populate our knowledge base with this data. It's also really important to choose a search method that we want to leverage. And this search method has to be adequate to the use case that we want to develop. And what search methods do we usually have available? So the first one is the traditional option, the traditional approach. So lexical search. This is the process of finding an answer to a question by means of keyword-based methods. What does this mean? This means that we are looking for exact matches for a given query in our knowledge base. But of course, we can define dictionaries or make use of NLP models to consider synonyms, spelling errors, or grammar errors. Just out of curiosity, lexical search is the search that is used by our service here at IBM, Watson Discovery. And basic lexical search is great when we have use cases in which the data doesn't tend to change. So for example, if we are searching for names, for dates, or for addresses, lexical search is a great option. It's really fast and it's really easy to set up. But we also have semantical search. It's a much more modern and cool approach that I'm sure everyone's heard about. It's really relevant in today's world. And it's the process of finding an answer not based on keyword exact matches, but rather on the context of the query. So this method helps us find data based on the contextual meaning of the search query. And this approach requires us to teach machines to understand and process the meaning of text. A few years ago, this would have been impossible, but thanks to generative AI and services such as Elasticsearch, this is actually quite feasible in today's world. However, it requires us to build vector embeddings and to build a vector database. So have a vectorial representation of our text chunks, which is not required in lexical search. I think a great example to know why semantic search is sometimes better and sometimes more flexible is the one we have here. So sometimes users will express themselves in a certain way. However, others, they will not use the specialized terms that are available in our documents. So for example, if I look at the IBM human resources document, for sure, I will see a lot of text talking about paid leave of absence. However, if I ask my HR bot a question, for sure, I will use the term day off instead of the other more specialized term. And so as you can see, lexical search might not be as flexible as semantical search because we are not looking into the context of the query, but rather into keyword searches. However, it has its drawbacks. It's much complex to build a semantic search engine. We need to go from our raw data to a unified document format, which in the case of our demo of our project, will be Markdown format. Then we have to chunk those documents into blocks of text. And finally, we have to generate those vector embeddings and vector representations of the text. For this last step, of course, we can use Elasticsearch. And in this project, for this previous step, we have used a Python script. This first step, we call it document conversion, and it's the process of converting the documents to passages of text. However, it's not a trivial task, especially when working with unstructured formats, such as PDFs or images. It's a really tough task to convert those documents into chunks of text. Why is this happening? Taking a look at a structured document, such a web page, when processing it, we can use the structural information to automate this document conversion. For example, I know this is a section because it has a section ID tag. I know this is a title because it has a title tag. I know this narrative text because it has a P tag. But when I look at PDFs, this is not as easy. You can see here that I have a section, but there's nothing, no structural metadata telling me that this is a section and this is a title. And this text belongs to this section title. And it's really important because in RAG, not only do we want to know from where we are retrieving the information, so not only from which document, but also from which section and from which page in the document are we retrieving that relevant information to generate an answer. But PDFs do not have an inherent structure metadata to extract. And so there is a need to apply OCR techniques and not just rule-based methods that could be applied in structured formats. But let's take this a step further. Let's look at tables. So it's very common to run into heavily structured data in the form of tables or graphs embedded in PDFs or images. For example, the one here, you can see a table that could be contained in a PDF talking about the schedule of a seminar. If we apply classic OCR techniques, then we will extract the text we can see here to the right. But is this text really useful? If I prompt a model with this table text and I ask the question, at what time and date does the second session of the XPath seminar start? And I prompt a Granite model. Just out of curiosity, Granite is our flagship models here at IBM. For sure, it will answer incorrectly, but this is not the LLM's fault, but rather it's our fault. Because as you can see, we have not given the LLM the structural information needed to answer the question. And so we can say that when dealing with tables, without structure, this information is useless, especially in further LLM applications, such as a retrieval augmented generation. And also, if we store the tabular data with its structural metadata, so for example, storing the table in HTML format, am I going to be able to perform accurate semantic search, given that the tabular data contains a lot of noise? If we look at a HTML table representation, you will see that there is a lot of noise and a lot of tags that might dilute the semantic meaning of the table itself. And so here we have the motivation of the project. So creating an efficient and robust RAG framework in which users can easily search through PDF files and find answers to their questions that is present in tabular data. And so taking this into mind, let's look at the solution architecture. So this is the architecture that we have built for this project. First, we will extract the original content from a web page. We will process it and chunk the the documents. Then we will make use of Elasticsearch to generate those vector embeddings. We will also make use of our service here at IBM, watsonx Assistant, to build the orchestrator of the solution and the virtual agent interface for the user. And finally, we'll make use of our generative AI platform, watsonx.ai, to give this RAG process the generation nature that it demands. So not only will I retrieve the relevant documents, but I will also generate a complete answer for the user. So let's now dive deep into the data processing and storage. So we have downloaded from a Spanish governmental webpage 300 PDFs. This webpage is the Spanish Official State Gazette's webpage, and it corresponds to a portal in which documents are published on a daily basis. And these documents corresponds to legal, administrative text, laws, decrees, court rulings, public notices, and many communications that are really relevant to the companies and individuals that interact with the government. And what I really like about these documents is that they contain a lot of tabular data. So it's great for our project. We have chosen 300 PDFs, so not that many, because the scale of the project is not really our objective. We already know that Elasticsearch can support thousands and thousands of PDFs, but we want to prove that we can build through Elasticsearch and watsonx a tabular Q&A system. Now let's look at the processing. Before uploading the data to Elasticsearch, we have to process and chunk those documents. So we have developed a Jupyter notebook that makes use of PyMu PDF LLM, which is an open source library for this document conversion process. And what we will do is chunk and break the documents into sizes of 300 tokens with an overlap of 100. I really like using an overlap because we ensure that a small portion of context is shared between adjacent chunks. And we have seen that this really helps preserve the cross-chunk context and really improve the efficiency of the system. With those chunks, then we are going to build a data frame with the following structure. So text, file name, page number, date of ingestion, date of creation, markdown code, and URL. But something really important from this data frame is that tables are not going to be chunked. So we are going to store them in isolation. This means that each table will be stored as a single row. However, the rest of the narrative text in the PDF will be stored as chunks. And then here in the text, obviously, we will store the text chunk that will later be used for the embedding creation, so the vector generation in Elasticsearch. Of course, the file name of the document, the page number in which this text chunk or table starts, the date of ingestion, the date of creation of the file. And now something really interesting. So we are going to store the markdown code, but we are only going to do this for the tables. So if the row corresponds to that table, then this table will be the markdown representation of the table. So the markdown code that appears in the document after the conversion from PDF to markdown code. And in that case, we will store in the text column a summary generated through generative AI of the table itself. So this is done so that we can perform semantic search over the summary. However, for the generation part of the answer, we will make use of the markdown code. And if this row corresponds to a narrative text, then the markdown code will be left empty. And finally, of course, the URL, so that we give the final user the traceability of going back to the document and searching for the answer. But how are we going to generate those summaries for the table representations, the markdown table representations? I made use of watsonx Prompt Lab, which is our generative AI platform to test and tune both LLMs and prompts. And we selected the Mixtral model with the following prompt. So as you can see, Given the following document, please generate a one-paragraph summary in Spanish. Please include all the key points of the table that differentiate the input table from the rest of the tables if there are in the document. And of course, if there is a title or a subtitle, please include them, because we have seen that titles and subtitles of tables usually contain a lot of semantic meaning in the of the table. And then we provide the complete document in Markdown format, so not the PDF, and the input table also in Markdown format. And we will execute this for every table that we see in the pre-processing. And why Mixtral model? So we have selected Mixtral model because it's the only model that has a big enough context size window in order to input both the complete document and the input table. And so the result is this. We go from a PDF table to a summary and a Markdown code, as well as all the metadata that we have previously seen. And this is great because now we are storing the structured metadata, and so the tabular information is useful in this RAG application. But not only that, since we are also storing a summary of the table, we can perform good semantic search over that column instead of the noisy table representation. And so now we can get this data frame and upload it to our Elasticsearch service. And so something like this will happen. As you can see, this project has been developed in Spanish, not in English, and so we had to make use of the multilingual E5 large embedding model instead of the ELSER model that usually comes in the Elasticsearch service. And why have we selected Elasticsearch? I think it's a really important thing to explain. So 1 year ago, we were looking into different services, and Elasticsearch had a few functionalities that were really useful for us. For example, it can be deployed over an OpenShift cluster. That here at IBM, this is a really good advantage because we are always look towards hybrid cloud. But also there were many functionalities not available on other services, such as hybrid search, and also being able to create those vector embeddings from the service itself and not having to create them outside and then uploading them to the vector database. Great. Now let's look into the next part, so the virtual agent. We have built our knowledge base, but now we need to build the orchestrator solution. And as I have previously said, this has been developed through our service, watsonx Assistant, which is a great service to develop virtual agents, and I think it really works well with Elasticsearch. So a virtual agent in watsonx Assistant is divided by actions, and actions define a set of steps that will be accomplished given a user's input. As you can see here, the actions are in Spanish, but let me just give a short summary. Here we have an action called how to use this assistant. So this is just an informational action. It explains to the client how to use the virtual agent. Then we have the global document Q&A. This is like the main action in charge of orchestrating the interaction between the user and the document retrieval system, as well as the generative AI model. And it corresponds to the main dialog flow. It will call the different sub-actions later. We also have an action to detect through generative AI the initial language of the user. As we will see, this is really useful. We have an action to translate the query to Spanish because our documents are in Spanish, but the query, as we will see, might not be in Spanish. We have an action to generate answers. So once we retrieve the context from Elasticsearch, we will make use of this action to create that prompt and to communicate with our LLM to generate an answer. We have an action to translate back the query, the generated answer to the original identified language. And finally, we have this transversal action, which is used by any other action that makes use of AI integrations, and it's simply to make the call towards watsonx generation API. And how does this translate to our system? So as you can see, I'm going to go back first. The user will have a question related or not to the documents that we have in our knowledge base. this question will go to our virtual agent, and our virtual agent will move it to the vector database. It will retrieve the documents with the corresponding metadata, and now it will execute the generative AI integration. So let's take a look at that. As I've said, this part is done by watsonx.ai service, which is, of course, our generative AI platform here in IBM. And what it will do, it will get the question and the relevant documents, and of course, the corresponding metadata. It will send this to the LLM through a custom integration in the watsonx assistant service. The LLM will generate an answer, which we hope is correct and it doesn't hallucinate. And then we will send back the answer to the user. So he or she will have the answer to the question. What model have we used for the generation aspect? So this project was developed a few months ago, and so we made use of Llama 2. Right now, at least at IBM, Llama 2 is depreciated. We make use of Llama 3, but back then this was the model I chose. So a Meta Llama for that generation aspect. And here we have the prompt that we are giving to the LLM. So first of all, we give a little introduction. You are a respectful, honest assistant. Always answer as helpful as possible. The typical things that are usually done in prompt engineering. Something interesting is that we are explaining our LLM what does the table code correspond to. So we are saying the table is in Markdown format. If there is a table code, then use the tabular information to answer the user's query. And of course, please do not answer something that includes harmful, unethical, racist content. This is just to be sure that our assistant is as respectful as possible. And as you can see here, we are retrieving the top 5 most relevant chunks from our vector database, and we are including them in the prompt. However, we do not know whether these 5 chunks will answer the question or not. This is up to the LLM to decide on which chunk to use. And now I ask the question, what if a user asks a question in a language other than Spanish? Can we make our solution robust to other languages? So this here in Spain is something really important because we live in a country with more than one official language. I come from Valencia, and here in Valencia we speak Valenciano. It's not the same language as Spanish, and so if we are building a virtual agent for the Spanish governmental portal, it's really important to have a virtual agent robust to the other official languages. And how are we going to tackle this issue? So the answer is simple. Through watsonx.ai, we can retrieve first the user's query, and instead of sending it directly to our vector database, what we are going to do is we are going to make use of a multilingual LLM to identify first the language of the user's message. For example, English. Let's say that, for the purpose of this process, we'll be making use of the Granite multilingual model, which is available in watsonx.ai. And it's one of our IBM proprietary multilingual models. What I really like about this model is that it's not that big, so it's really efficient and really fast. And so it fits great for this translation and language identification process. Then, of course, we use this Granite model to translate the query to Spanish. We will send back the query to the virtual agent, and the virtual agent will, again, repeat this process of answer retrieval and retrieve those chunks of text that might answer the user's query. And now, of course, the answer will be generated in Spanish. However, we can make use, again, of that multilingual large language model, the Granite one, to translate it to the original language. And so now the user has a an answer in English, and we are all happy because he has a correct answer and in the language that he desires. Great. So the presentation is always good, but let's look at a real life demonstration. So here I prepared a video of the solution. I'm sorry that the text is in Spanish. I will translate. I will do my best. So here we can see the portal of the Spanish Gazette office. And there, down to the right, we have the virtual agent that the user can click. First, they are going to ask how to use this agent. And of course, here we have a long text explaining how the agent works and how they can use this agent to ask questions about specific documents and retrieve both the answer and the source of information. So here the user has selected, I want to ask a question. And the virtual agent will first say, great, please give me an ID for the document. Of course, we could skip this step and allow the agent to ask questions towards the whole set of documents. However, I wanted to perform a hybrid search, so not only a semantic search on the documents, but also a keyword search to filter out those documents that do not belong to the ID input by the user. And I like to do this because it really reduces the scope of the search. I think this is a really advantageous step because it improves the relevancy of the retrieved results. But just know that it could have been done such that the user does not need to include a document ID and just ask a question and search through all the documents in the portal. And now they will type in a question in Spanish. Oh, sorry, an ID first. And now the virtual agent says, great, what do you want to know about this document? And now the question here is, I want to know the name and the position of the person that was given the job mentioned in this document. So we hit enter. Given that this query is in Spanish, we're not going to translate it. So we are doing a few less generative AI integrations. And here we have the answer. So here we have the name and the position of this person. And of course, we are giving them the URL to this document so that they can actually verify that this answer is correct. So this is the original PDF. And as you can see, this is the name that appears in the answer. So we have a query in which the answer is contained in a table, and our solution has understood both the structure and the content of the table to answer correctly to our user. So it's combining both columns to generate the complete answer. Now the user is going to ask a follow-up question. So here he's asking, or she's asking, what are the contact information of the position that has been given? So how can I contact this person? And the LLM is answering, there is no contact information available in this document, which is this here. And if we go back to that PDF, you will see that there is actually no contact information included in this table. So now let's try with a different document. For example, the one used as an example here. And here we are asking for the identification number of a specific company in Spanish as well, so no translation. And we get the answer there. So B042, if we go to that document, we'll see that that company has that identification number, so also B042. And so again, we have a great example on how our solution understands the structure of the table. And now here, let's change it a little bit. Let's ask on a language different to, well, no, this is in Spanish as well. So here we are asking another question, and of course we will receive a correct answer. Yeah, so here you can see that there's the information to answer the query. I think the next question is not in Spanish, which I think it's more interesting to see. So here, this one in English. How many public registration registries and which ones appear in the table of the regional unit of Catalonia? And as you will see in the document, there are many tables, but there is just one talking about Catalonia. Yes, so it's saying there are two, one for Barcelona and one for Girona. And if we go to the PDF, we will see that, in fact, if we go to the table of Catalonia, so this one here, there are two being mentioned in the table, so Girona and Barcelona. And so we have seen that our system is robust to languages other than Spanish and other than English, which is also important. Right. Now let's look at the project outcomes to finish this presentation. This is a great solution, very tolerant to dynamic data. If new information is added to the vector database, we do not need to change the internal action flow of the virtual agent, and neither the prompt being set to the LLM. And this is something very good because we can now control in Elasticsearch what is the data being answered to our users. We are also democratizing the value locked away in these documents. Before this virtual agent, only those citizens or companies with a lot of experience working with this portal would be able to find the answers to the questions they have at the correct time. But now anyone can query, no matter the language and no matter the place in which this information is contained. This, as a result, there is data self-service. So everyone has access to the correct data at the correct time. And also, since the scope of the LLM is reduced, because we are asking for that document ID, and that we have grounded the LLM with contextual data, thanks to Elasticsearch, the LLM is not as prone to hallucination as if we would have asked the question directly to the model. And finally, what I really like is that our solution can efficiently handle tabular data, that, if you recall, was the motivation of this project. And also, I think this project really represents the vision we have here at IBM towards generative AI. So there are multiple LLMs working on the same goal, and also there is no LLM to rule them all. It's something we always try to teach and show to our clients, that no matter the use case, we should never focus on a single huge generalistic LLM, but rather small ones that accomplish the task even better. And we can see the importance of having an open generative AI platform that allows us to test and to work with different AI models, such as watsonx. And possible future work, how could we extend this project even more? So we could connect this to the client-owned endpoints. So not only an informational virtual agent, but also a transactional virtual agent, so that it could retrieve answers to the queries, but also maybe do something for the final user. So maybe if we are talking about incentives, so not only retrieve information about this public incentive, but also apply for that incentive, all from that virtual agent. And also we could connect this solution to watsonx governance. watsonx governance is a service here at IBM that provides this governance layer that many companies and many governments are asking for. So how can we control that our model is acting correctly and is not hallucinating and it's not being biased? So we would do this through watsonx governance. We could also implement role-based access control, such that only specific users have access to specific documents. We could perform a voice integration. I think this is really useful because now through voice, users could perform this augmented search and retrieval through the telephone channel, for example, making it even more accessible to those citizens that cannot type, for example. And finally, we could even do a GAR framework, so not RAG, not retrieval augmented, but generation augmented. This means to automate, for example, the entity extraction from the user's query and understand to which set of documents should we redirect the question. So instead of asking for a document ID, we could just let the user say, I want to know this about this document, and automate this entity extraction to extract the query as well as the document ID. And so that was all my presentation. I hope you like it. And of course, please feel free to add me on LinkedIn. For sure, I would love to talk further about this project. And now any questions are welcomed.
Thank you very, very much, Javier. That was really, really interesting. There's all sorts of really cool additions you've done to the standard RAG framework. One thing that I really appreciated was your statement, no one model to rule them all. Can you kind of touch on that? Like the reasoning why you prefer like multiple smaller models as opposed to like one, which is kind of has been the standard, but you know, we're always interested in starting better trends.
I really like this question. I think it's incredibly relevant in today's world. I think from my point of view, at least, huge generalist models are great at performing many tasks, but they are not excellent at performing maybe something very specific. And so there is a need to adapt those models to the context of the use case. And so that's why we think here at IBM it's really useful to make use of different models that have been trained with different data and that are usable for different use cases. So we should never select the same model for every use case, but rather select the model that has the training, the size, and the variables that are suitable for our use case. For example, in the summary generation, it's really important to select a model that has been trained with Spanish data, of course, because it needs to understand Spanish, but also that it has a high context window. And on the other hand, for the answer generation, we do not need this large context window. We can make use of a maybe more generalistic model and a larger model to generate the answer. On the other hand, in the translation aspect, we really need a model that has been trained for multilingual use cases, which is the case for the Granite one. And so it's really important to always select the LLM that's most appropriate for the use case.
That makes total sense. And thinking about like the work of translation for some of these questions and how you might have to repeat a bit of the loop, a bit of the process, how easy would it be to possibly cache some of these questions and answers to kind of prevent that repeat in the future? Yeah,
that's a really good way, I think, of accelerating that answer generation. I think it would be really good. Maybe it depends on the use case. If there are some questions that are repeated many times, you could even type the answer statically in the virtual agent and just detect this user query and directly not even generate an answer, just show it to them. But if we are dealing with data which is very dynamic and is changing weekly, then this option is not as good maybe as going to Elasticsearch, retrieving content, and then generating. But yeah, of course, I think it would be a great addition to the solution.
Yeah, that is an interesting use case. I could see that sometimes you would have like hot PDFs or hot questions as like
Exactly.
something interesting happens within the government, but also some things just sort of like dying out. So that would be actually a pretty challenging cache policy. And then now I'm seeing watsonx agent. How can new users or users that have never actually engaged within Watson, how can they approach watsonx? What are some good resources?
Yeah, of course. You can go into our IBM Cloud page. I can also add a link. I don't have it right now, but there's a link where you can interact with our Granite models to test and to play with them. But of course, feel free to join our IBM Cloud page, and you can test our models in the watsonx.ai platform, which is our generative AI platform.
That's awesome. That's awesome. And then one question, a little bit from the beginning. This is getting into a little bit of the weeds, but I saw that you're using the Python library PyMu PDF for LLM. And I have worked with PyMu, and I was wondering if you could kind of talk on the for LLM, like what does the library provide to make your RAG framework just a little bit smoother? I saw that for LLM suffix. I was just hoping that you could kind of talk upon that.
Yeah, the thing is that when dealing with tables, we really need a library that completely understands them, because if we want to extract both the structure and the tabular information, we need a library that is able to do so, no matter the input format. So for both PDFs and images. And PyMu PDF for LLM is an open source library that achieves this incredibly well. It's also pretty fast, and at least with my data, it has worked incredibly. So extracting that correct tabular representation of the tables present in the PDFs.
Awesome. I am excited to try this then. I actually haven't tried the 4LLM version of this library. So yeah, learn something new every day on this stream. Thank you so much. And those are the questions I actually had. If we have any further questions from our chat, please feel free to throw that in. Yeah, this is extremely exciting and really great work. It's very fast, it's very relevant, and yeah, I'm actually going to go to I'd love to give this a try out. Do you have like a repository, or is this this Jupyter notebook available to the public?
I will make it available. I can share it with you, and we will share it with anyone that wants to take a look. It's a pretty simple Jupyter notebook. It's not really tough to understand. Maybe the difficult part is to see how it identifies what corresponds to a table and what corresponds to narrative text. But apart from that, it's really simple to follow.
Awesome. Awesome. Well, thank you so much. I really appreciate this presentation. It's very thorough. It's very, easy to follow along with it. I can see that you've worked really hard on this and you've dedicated a lot of time to this. I appreciate that. Thanks.
Thanks a lot. And thanks a lot for the opportunity to letting me talk. I hope it was not boring enough, and I hope at least someone has learned something new.
No, it's very, very exciting. Thank you so much.